Back, my sixth graders, we're going over greatest common factor, lesson 3-2. Let's begin. You're saying find the prime factorization of each number. If it is prime, write prime. Well, what number multiplied to 3 would give me 27? That'd be 9, of course. And what is two numbers give me the product of 9? That'd be 3 times 3. Next, we got number 16. That's yours to do. I'll be doing number 17. Now, I know 26 is an even number, so 26, I know, can be divided by 2, which would be 2 times 13, and these can't be broken down anymore, so that's it. Number, let's see, 19. Find the greatest common factor for each pair, 21 and 49. Well, I know 21 is the product of 3 times 7. And really, there's no numbers that go into 3 or 7, so I have to stop there. And then I got number 49. And I know that is 7 times 7. And again, there's no numbers that go into 7, so we stop there. What is the greatest common factor? Well, the greatest common factor is going to be the one that's in both of these, which would be 7. Next, we got number 21. We got number 32 here. Again, it's an even number, so I know I can go ahead and divide it by 2. And that's 2 times 16. But I know 16 is really 2 times 8. But I know 8 is really 2 times 4. And of course, 4 is 2 times 2. That's a lot of 2's there. So 32 has 2 times 2 times 2 times 2 times 2. Now let's look at 81. I know 81 to find is the product of 9 times 9. I know 9 is really 3 times 3, which means this 9 is also 3 times 3. And I realize there is no common factors here, which means the only common factor, if we had used the rainbow method, would be 1 times 32 and 1 times 81, which means 1 would be the greatest common factor. All right, we're on number 23 now. 23 says, use the greatest common factor and distribute properties to find each sum. Well, if I did that, I would go ahead and break up number 34 first. I know 34 is the product of, well, it's an even number, right? So that's going to be 2 times 17. Can't break those up anymore. So we'll go over here to number 51. And you might not realize it by looking at it first, but if you divide 51 by 3, you get 17. So the greatest common factor is going to be 17. To use this distributive property, I would put 17 in front. In parentheses, well, 17 times 2 is 32. And 17 times 3 is 51. Now I could go ahead and solve it by saying 2 plus 3 is 5. And that would make this 17 times 5. Well, if I took 17 times 5, that would give me 85. So let's see if that works. 85, that doesn't match up to me taking 34 and adding it to 51. Well, 4 plus 1 is 5, and 3 plus 5 is 8. And there we go, 85 is our answer. Now, we answered it this way using the distributive property, because over here we would have had it distribute. So we factored it out using distributive property. Now I'm on number 25. Find the least common multiple for each one. And if I did this, I would take 12 and realize that the only numbers that make up 12 are going to be 3 times, well, actually it could be 2 times 6, couldn't it? Let me fix that. 2 times 6. And I know 6 can be made up by multiplying 3 times 2. Number 11, that's going to be pretty easy because nothing goes into 11 but 1 and 11. So realize that the least common multiple, we're trying to find a number that, well, let's see, this would be 11 over here and 1, right? So we're talking 11, and then we're having to multiply it to all the numbers here that are prime. So we're talking 12, right? Because all these numbers multiplied together will give me 12. There's nothing in common to go ahead and eliminate. So this is going to be 12 times 11. You could kind of look at it like if you were working with fractions and you were adding them. You're trying to find what is the common denominator. You realize that there's no numbers that these two go into, so the only thing you do is multiply them to each other, and that means the least common multiple is going to be 132. I know this because 12 times 11, that's going to give me 12, and then 12, and when I add them together, 2 comes down, 1 plus 2 is 3, and the 1 comes down. So 132 is the answer. Number 27, I got 5 and 8. If I break these up, 5 is just going to give me 1 and 5, right? And of course, 8 is just going to give me 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8. There's nothing in common up here and here to eliminate, so basically we got 5 times 8, and that means this is going to be 40. That's my least common multiple. All right, I'm going to be doing number 29 now. To celebrate its grand opening, the store is giving customers gift certificate. Which customer is the first to get 2 gift certificates? We got every 8 customer here and every 6 customer here. I take 8 and I see what breaks it up. I know that's 2 times 4, but I know 4 is really 2 times 2. And when I get to 6, I know that that is the product of 2 times 3. All right, 8 has a multiple of 2 in it more, so we're just going to use their 2. And that's going to be 2 times 2 times 2, which is going to give me 8. And then I have to go ahead and multiply it to the multiple here that isn't used, right? Because this was the common one. So that's just going to be 3. And that would give me 24. And when you think about it, if we have 1 over 8 and 1 over 6, all right, every 8th customer is 1 out of 8 customers. Every 6 customers is 1 out of 6. We're looking for that common denominator, right? So that's going to be 24. All right. All right, number 31 says you have 50 blueberry scones and 75 cranberry scones. You want to make as many identical bags as possible. Each bag should have an equal number of blueberry scones and an equal number of cranberry scones. What is the greatest number of bags that you can fill? All right, we're trying to get an even number of these, so we're trying to find out what is the greatest number of bags that we can go to fill. Well, since it says what is the greatest number, we know that we're looking for the greatest common factor. When we take 50, and we look for the multiple of it, what numbers multiplied together will give me 50? We know that 2 and 25 will work, right? We know 25 can be broke up by 5 times 5. And then we're kind of stuck right there because these are all prime numbers. Now we got 75. 75 can be found by taking 3 times 5, or 25, excuse me. And again, 25 can be broke up by 5 times 5. And we found the greatest common factor. We realized, well, we got 5s, right? Times 5, right? That's a set, and that's a set. And 5 times 5 is 25. So 25 is the greatest common factor. So what is the greatest number of bags? We can make 25 bags. There would be, let's see, there would be 2 blueberry scones in each bag, and there would be 3 cranberry scones in each bag. Okay. All right, let's move down here. I already think in question, Gina has 20 trading cards. Sam has 91 trading cards, and Tiffany has 49 trading cards. Use the greatest common factor and distribute properties to find the total number of trading cards that Gina, Sam, and Tiffany have. Again, find the greatest common factor of 28, of 91, and of 49. When I look at this, I know 98 is made up of, let's see, I would say 4 times 7, right? And then I could go ahead and say that 4 is made up by taking 2 times 2. 91, let's see, what goes into 91? Wow. I know 2 doesn't. I don't think 3 does. I believe 5 does. 7 might. Let's check that out for a second. If I take 91 and divide it by 7, 7 goes into 9 one time. That would be 7 here. 21 would be left over, and 7 goes into 21 3 times. So that's 13. So that's going to give me 7 times 13. Okay, can't break those up. 13 up at all. And then we got 49, and that's 7 times 7. I can't break that up either. So the greatest common factor is going to be 7. So that would be 7 times, well, 2 times 2 is 4. And then it would be plus 13. And that would be plus 7. And now, if we're using distributive property, we would add these together, right? I got 4 plus 13 plus 7. 13 plus 7 is 20, so this would be 7 times 24. All right. And then, well, what would 7 times 24 be? 24 times 7. That would be, let's see, 28. 2, this would be 14, 15, 16, 168. Now, does that equal all these put together? Well, if we took all these numbers, 9 and 1 is 10, plus 8 is 18. Carry the 1. We got 9 and 1 is 10, plus 2 is 12, plus 4 more would be 16. So 168, and that's exactly what we got over here. That works. All right, number 35, people are waiting in line for the theater premiere. Every 5th person in line will receive a free theater ticket. Every 6th person in line will receive a gift card for $40. Which person is the first to receive both? Remember how we said this? It's almost like having 2 fractions here, right? This one's 1/5, and this one's 1/6. We're looking for the common denominator, right? Before we can add them or subtract them, we're looking for the common denominator. I know the common denominator of 5 and 6 is going to be 30. Let's see how that compares to how the book told us to do this. If I'm looking at the number 5 for the 5th person, right, that would give me 1 and 5 as my numbers, okay, that factor into 5. And then we have 6, and that's going to be 2 times 3. As you can see, none of these numbers are the same. So we're going to take 2 times 3, that's 6, and then 5, we have to multiply all this together. We're not getting anything eliminated. So this is going to become 30. And I believe that's all the problems that I had to do today. Looks like you guys got the rest. I'll see you in class, and good luck.